There is a number printed in the technical datasheet of almost every solar panel ever bolted to an American roof, and almost nobody who buys one is ever shown it. The number is 77. Above 77 degrees Fahrenheit, a standard silicon panel begins to lose power. Not in some distant failure mode, not after years of wear, but immediately on the hottest, brightest, most productive day of the year. The thing you paid $30,000 to capture the sun is quietly throttled by the very sun it was built to catch. If you are the kind of person who likes to know how the object on your roof actually behaves, rather than how the brochure says it does, this is the channel for you. So stay with me, because once you see this flaw, you cannot unsee it. Start with the part of the story that surprised me most when I went digging through the manufacturing figures. The silicon itself, the blue rectangle everyone pictures when they hear the word solar, is now astonishingly cheap. A raw panel off a warehouse shelf can cost less than 50 cents per watt. So where does the $30,000 go? Not into the cells. It goes into people and paperwork. It pays the certified electrician who cuts into your breaker panel, the city permit, the zoning inspection, the engineer who checks your rafters, the steel racking, the contractor's markup. The industry has a polite phrase for all of it. They call it soft costs. And on a typical home installation, those soft costs are the majority of the price. You are not really paying for sunlight. You are paying for permission. Now hold those two hidden facts together, the heat penalty and the permission tax, because every machine I'm about to show you exists to defeat one or both of them. And they are not prototypes in a university basement. Every single one is something you could order this year. Take the heat problem first, because there is a company that did something almost paradoxical with it. Naked Energy, a British engineering firm, looked at the fact that hot silicon bleeds power and asked a stranger question. What if the heat wasn't waste at all? Their Virtu system doesn't lay a flat board in the sun. It seals each high-efficiency solar cell inside a cylinder of borosilicate glass, and then it pulls the air out of that cylinder to create a vacuum. A vacuum has no air molecules to carry heat, so the tube behaves like a thermos, trapping the sun's warmth inside. Beneath the cell runs a thin channel of glycol fluid that actively strips the extreme heat off the silicon. It is pumped straight into your hot water tank, hot enough to reach around 175 degrees Fahrenheit. One panel, the same patch of roof, doing two jobs that normally fight each other. The enemy of the ordinary panel becomes a free water heater. Now pull a different thread, because heat is not the only thing that quietly destroys the value of rooftop solar. The mounting does. To fix a conventional array to your house, a crew drives dozens, sometimes hundreds, of steel lag bolts straight through the waterproof skin of your roof and into the wooden rafters. Every one of those holes is a future leak, held back only by a rubber gasket and a bead of sealant. Worse, it sets a trap. If your shingles are 10 years old when the panels go up, then 5 years from now, when those shingles fail, you must pay a crew to dismantle the entire array, pay a roofer to redo the roof, and pay the solar crew all over again to put it back. Most homeowners never hear about that trap until they are standing in it. I will be honest, when I first read how the next company sidestepped that, I actually laughed at how obvious it was in hindsight. GAF Energy stopped treating solar as an electronic gadget you bolt onto a roof and started treating it as the roof. Their Timberline product is a nailable solar shingle, the only solar product formally certified as a primary, water-shedding roofing material. The photovoltaic cells are laminated into a flexible architectural shingle that lies flat against the deck, shooting nails straight through the top edge, overlapping each shingle so the electrical connections snap together as they work across the roofline. No specialized array, no steel rails, no separate solar company. One crew, one permit, one roof that happens to generate power. If your house needed a new roof anyway, the most expensive part of going solar just disappeared into a job you were already paying for. If a single hidden number like 77 can change how you see the panel on your neighbor's roof, then you are exactly the sort of viewer this channel is built for. And there are dozens more of these buried engineering stories waiting on the channel, so consider sticking around for them. because the permission tax has its own assassin, and it looks less like industrial equipment than like a household appliance. The EcoFlow Stream Ultra is a compact box holding a lithium iron phosphate battery, a charge controller, and here is the disruptive part. You do not wire it into your breaker panel at all. It plugs into an ordinary wall outlet. No electrician cutting into your panel. No permit office. No utility approval. And when the grid fails in a storm, a normal grid-tied system shuts itself off to avoid backfeeding the lines, leaving you dark on a roof full of sun. This one doesn't. It simply keeps your fridge and your phones alive from its own battery. The $30,000 permission tax shrinks to the price of one appliance you install yourself. Then there is the flaw nobody even counts as solar, because it is hiding in your windows. In summer, glass is a thermodynamic hole in your house. Sunlight pours straight through it, the room overheats, and you burn money running the air conditioner just to pump that heat back outside. A company called Solar Gaps asked why you would block that light with a dumb curtain when you could harvest it. Their product is an exterior window blind where every horizontal slat is a monocrystalline solar cell in a weatherproof shell. But the clever part is motion. A small motor and a light sensor tilt the whole array of slats through the day, so the cells keep facing the sun at the ideal angle from morning to evening, something a fixed roof panel can never do. From the street, the window looks like it is slowly breathing, and it pays you twice. By shading the glass, it blocks up to 85% of the heat trying to get in, cutting cooling bills by as much as 30%, while the same slats feed electricity down a hidden wire to a small indoor inverter that plugs into your wall. A renter with no roof access suddenly has a power plant hanging outside the window, which brings us to the machine that gathers every one of these ideas into a single object sitting in a backyard. At night, it looks like a sealed, armored cabinet, low and silent, but at dawn the smart flower wakes up and physically unfolds. A robotic arm spreading a great circular fan of dark blue solar petals until it looks exactly like the thing it is named for. Then the whole head begins to turn. Using dual-axis tracking, it locks onto the sun and follows it across the entire sky, holding a perfect 90-degree angle from sunrise to sunset, while a fixed roof panel only catches that angle for a couple of hours at noon. That single act of movement lets it generate up to 40% more electricity than a static array of the same size. Suspended in open air, it cools itself in the breeze that a roof panel never gets. Every morning as it unfolds, brushes mounted behind the petals sweep dust, pollen and snow off the glass, so it cleans itself without you ever touching a ladder. And built into its base is an anemometer, a wind gauge. When a storm crosses a dangerous threshold, the smart flower does not wait for you. It folds its petals back into its steel base and locks down until the wind passes, then opens again the next morning as if nothing happened. So look back at that number we started with, the 77 degrees that quietly throttles the panel on your roof, and notice what every one of these machines has in common. None of them except that the solar panel must be a flat, fixed, fragile board you nail to your house and then fight against. One turns the heat into hot water, one becomes the roof. One unplugs itself from the entire bureaucracy. One hangs off your window, and one simply gets up every morning and chases the sun. The cheapest part of solar was always the silicon. The expensive part was everything we built around it to stand still. Right now, one of those smart flowers is sitting open in someone's yard, tracking the sun across the sky, generating power its owner's neighbors don't even know is possible. So tell me where you land. Is the future of home solar, the boring panel on the roof, finally getting smarter? Or is the whole rooftop idea already a dead end that these machines have quietly replaced? Drop your side in the comments. I read them, and if you want the next overlooked piece of engineering most channels will never bother to explain,